Welcome back to my YouTube channel. Mr. Sam here once again, and in this video we are going to be discussing differential calculus. Alright, so let's get into the general rule of differential calculus. You can summarize it as thus. If y is equal to ax raised to the power n, then dy dx is equal to a times n x raised to the power n minus 1. Now, a is the coefficient of x, n is the power of x. The power can be a negative number, a positive number, a whole number, or a fraction. So you just simply subtract 1 from the power and multiply the coefficient and that power together to find the differentiation of that function. Now, I should also mention that differential calculus is not always dy dx. If you have something like this, y equals 2x plus 3, this is a function of y in terms of x. So write this one as dy dx. But if it is a is equal to, say, 2b plus 3, this will be written as dA db, and it is still differentiation, that is the differentiation of a with respect to b. This means the differentiation of y with respect to x. So the letters that are given in the expression equation is what we are going to be using as our dy dx or dA dd or ds dt or whatever. So I think you should get that. So we are using dy dx because this is like the common form. Now let's take some examples to explain how to use this. Alright, so this will be our first part of the examples. Let's see how we can use this rule of differential calculus to solve the following questions. Solution number 1, we have y equals 4x raised to the power 7. Following this rule, we simply multiply the coefficient and the power. So y will be equal to 4 times 7, then x raised to the power, we subtract 1 from the power, that is 7 minus 1. So, sorry, this is not y, this is dy dx. Pardon me for that mistake. So 4 times 7 is 28, then x raised to the power 7 minus 1, that is 6, and that is the answer to that question. Number 2, we have y equals 3 over x squared. Now, this is expressed in fraction form, but we cannot apply the rule unless it is in this linear form. So what do we do? You should remember indices. Mind you, if you are watching this video and you have not watched my video on indices, you don't understand indices very well, do well to check the channel for that video. Watch it. It will help you understand indices better from scratch to finish. I've done justice to that topic in that video. Now, what we are going to do here is simply, first of all, we have to understand that this fraction is 3 times 1 over x squared. 3 times 1 is the same thing as 3, so this will become this. But we want to take this as a single unit. Remember the rule of indices that talks about negative indices. So this will become x raised to the power minus 2 times 3. So this y is equal to 3x raised to the power minus 2. So this is the linear form. Now we can apply the rule. So we can say dy dx is equal to 3 times minus 2, that is minus 6x raised to the power minus 2 minus 1, that is minus 3. Now, do we leave an answer like this? No, we do not leave negative powers in our final sign mathematics. So what do? We know that this is minus 6 times. This one is 1 over x raised to the power 3. That is the of the minus there. So that will be minus 6 over x raised to the power 3, and that is our final answer. Now, number 3, we have 5 roots x. From our knowledge of indices, we know that the square root of x is the same thing as x raised to the power 1 over 2. So basically, what we have here is we have y equals 5 roots x, that will be equal to 5x raised to the power 1 over 2. So now it is in linear form. Let's apply the rule. So what will be dy dx? Dy dx will simply be 5 times 1 over 2, then x raised to the power 1 over 2 minus 1. So 5 times half is 5 over 2. Then if you subtract 1 from half, you should be having minus half also. That's minus 1 over 2. So what we have here is 5 over 2 times this minus means 1 over x raised to the power 1 over 2. I will know x is power 1 over 2 is square root of it. So we can bring it back to our final answer. And we have 5 times 1, 5 over 2 times 2 equals x. And that is the answer for this question. Let's look at number 4. Okay, y is equal to 4. Now 4 is a constant. Why? Because there is no exotic, no unknown, no variable. So what do we do in this case here? We can assume that there is an x. So if I'm going to bring x with 4 and we will not change the value at all, it will still be 4, then the power of x will be 0 because x is power 0 is 1. So it's more or less like that, say 4 times 1. So I can say this is the same thing as 4x is power 0 so that I will not apply the rule. After this example, if this is your first time doing it, you might not need to do this anymore. So the y dx now will be what? Well, 4 times 0, x is power 0 minus 1. 4 times 0 is 0. 0 times everything is equal to 0. So whenever we are differentiating a constant, it is always 0. This is just to show how we get this 0 that we are trying to explain there. And that is the answer for now. And then number 5 is a very easy one. Y is equal to 7x. What is the power of x here? It is 1. So what will be the y dx? The y dx will be 7 times 1. Then x is power 1 minus 1. That is 7 times 1, 7. X is power 0. X power 0 is 1. And the answer will be 7. So if you differentiate something like this, where you just have a number and x alone, to give you the coefficient. So if I differentiate y equals x, the y dx will give me 1, which is the coefficient of x. If I say y equals 13x, the y dx will give me 13. It's as simple as that. That's the first example. If you do not really get it, you can rewind and listen to it again. Just try and follow through. You understand. Now let's get to the second example. So now we have our second example where we have to find the derivative of each of the following. When we have to find the derivative, the same thing as differentiate. So we have to find the derivative of all these questions. We'll take this form, and with that you should have mastered the general way, after which I will give you some exercises to also practice it as usual. Number 1. We have y equals 2x cubed minus 4x squared plus 6x minus 1. So we differentiate each of them like that, just like I've done in example 1. So dy dx will be equal to 2 times 3, that's 6x raised power 3 minus 1, that is 2. Minus 4 times 2, that is 8 x raised power 2 minus 1 is 1, so the power of 1 is 1. Of x here is 1. Then plus, if you differentiate 6x, like I said earlier, to give you 6. Differentiating 1, since a constant, will give us 0. So this is our final answer. Number 2, we have y equals 3x squared minus 5x all over 2x. Now, suppose what we have down here is more than a 10. We have 2x plus 1. We are going to apply a rule of calculus, which we'll be making a video on very soon. But this is not going to be solved that way because you just have 1 term here. And the beautiful thing about having just 1 term denominator is that you can split it for the two of them. So this can be written as 3x squared over 2x minus 5x over 2x. So if you find the LCM of this, it will give you this part. So why are we doing this? So I can simplify. Here x can cancel x, and here x can cancel one of the x here. So that y will be equal to 3 over 2x minus 5 over 2. So in some cases, you have to first simplify before you start differentiating. Take note of that. So now dy dx. The power of x here is 1. If you differentiate 3 over 2x, since it is just 3 over 2 direct quotient, our answer will be 3 over 2. Differentiating 5 over 2 will give you 0, since it's a constant, there is no variable. This is our answer, which is 1 over 2. That is the answer to this question. Number 3, we have y equals 2 over 3 x to the power 4 minus 4 over x cubed plus 9. Now for this one, we'll just start right away. Okay, sorry, before we start, we have to make this one become linear form, and that is going to be 2 over 3 x to the power 4 minus, this is 4 x to the power minus 3. If you listen very well to the first example, you'll start by it here, plus 9. Now, the y, the x, we're going to multiply these two. So we have 2 over 3 times 4, then x is to the power 4 minus 1. Here, we have minus 4 times the power minus 3, then x is to the power minus 3 minus 1, then plus, if you differentiate 9, it is 0. But I might as well not show it, but let me just put it there. Now, multiply 2 times 4, that is 8 over 3. Here we have x is to the power 4 minus 1, 3. Minus times minus is plus 4 times 3 is 12. So we have 12 x is to the power minus 3 minus 1, which is minus 4. So the next thing that we find here is, and that will be equal to, so our final answer will be 8 over 3 x cubed plus, because of this minus, that is 1 over x power 4, the answer will be 12 over x is to the power 4. And that is the answer to that question. Now let's move to number 4. Number 4, we have s equals 40 plus 1 over square root of 2 raised to the power 3. In this case, it is s here and t here. So it will be the s, the t. But can we go straight yet? No. Because we have to simplify this guy, make it a linear form so that we can now apply the general rule of the y here. So what do? We can make use of our knowledge of indices here now. So s will be equal to 40 plus, this is 1 over, the square root of t is t raised to the power 1 over 2, and t is time power 3 here. So we have 3 times 1 over 2, and that will be 3 over 2. So the whole of this is 3 raised to the power 3 over 2. Now, the 1 over here is from negative limits. That will be equal to 40 plus t raised to the power minus 3 over 2. So the 1 over. And now it's in a linear form. So let's find the s, the t, that is differentiation. If you differentiate 40, you get just 4. And if you differentiate this one, that is plus, the coefficient here is 1 times the power times minus 3 over 2. Then t raised to the power minus 3 over 2 minus 1. Now let's finish it. We have 4 plus 1 times this, that is plus times minus 3 over 2. Now let's simplify the power here. We have minus 3 over 2 minus 1, put over 1 here, find the LCM. That is 2 here, that is minus 3 minus 2, that is minus 5 over 2. So we have t raised to the power minus 5 over 2. So the rest depends on our knowledge of indices. To simplify, we have 4 minus this is 3 over 2 times the minus here 1 over t raised to the power 5 over 2. 5 over 2 is 5 times 1 over 2. So separating the 1 over 2, which is the square root, that can be square root of 5 of t now raised to the power 5. So this is the same thing as this. So 3 times 1 is 3, and 2 times root this, that is 2 roots t raised to the power 5. That is the answer to the question. That answers the examples that are given in this video. If this is not very clear, go back, try and follow through again. You understand it. And if you have not watched my video with indices, check the channel and make sure you watch it. I'm emphasizing on it because most of the topics in mathematics will refer back to the knowledge of indices. So it's good to know indices, very, very important. So now I'll be giving you some exercises to go and practice with, and that will be the end of the video. So here you have it. These are the exercises for you to practice with for this video. Make sure you try them, and then if you do not get anyone, try and go over the examples again so that you will understand this very well. And remember, indices is very, very important. It's very important in calculus if you don't know before. Now you are hearing that for the first time. So take notes of that. Share the video with your friends, and then invite them to also subscribe to the channel. I will see you in the next video where we're going to discuss further on differential calculus. Thank you very much for watching.